Oh, I forget. So I think I can just touch on. Let me just. There is a part that I left out. I feel that is good to check on. As this. Let me just open this. Let me just share something here. Just a minute. Just a minute. I'm looking for a file here. Yeah, I think I've gotten these. Did we cover something on combining the margin datasets? I don't think we did that. So that is what I think I shared with you. That is lecture 10 and 11. So I think we should check that. And there is also a file that I'm checking on EDA. But I don't know what happens with the rest. Let me just share my screen. I was looking at lecture. That is lecture 10, 10, 11. That is just right here. Yeah, I left out these combining and merging data sets. So if there is no question on visualization, and I think I'm hoping that we are good in data visualization, um, so that we can at least check on how to combine and merge data sets. And then I'll also check for that file on that theory part on EDA. I don't know why I'm missing that file, but I'm hoping maybe by the end of this combining and merging datasets, uh, I will have gotten the file. So this is something that we didn't cover, and what we are going to cover here is how to merge data frames, margin on index. We can also have a margin on multiple columns, and we can have combining with join method, and combining numpy array. We'll also check combining with concat method. So these are some of the things that you will have to do in case you have different maybe data sets that needs maybe to be joined. So to start with, we can start maybe see how you can merge data frames. Uh, I think that was it assignment number 2, where you guys were thinking that I was asking for combining of I was asking something to do with merging data frames. So I think from these we can see how you can maybe merge data frames. So it is quite easy how we merge data frames, because you just need to define your data frames. Like in this case, we have a data frame that is D1, and in this data frame we have it's a dictionary here. It's a dictionary that we are converting into a data frame. Since you can see a key, I think you can see a key here and some values in a list where we have maybe something like A to E. Um, we have also another key here that is num, and we have just put a range of 4. So the other data frame that we are going to have is data frame D2, and you notice that here we have some values also, that is A, C, E, F, So we have another key that has a range of 4. Um, I think by now you already know how to convert these dictionaries into data frames. So now if you need to merge them, you're going to use we have in pandas we have a method that is called merge. Merge is a method that is going to help us to merge these data frames. So I think we can see this in action. Let us have just a cell here, and just try to copy these. Let me someone here. Okay, so I think you can just see these in action here. Yeah, you can see these in action. Let us just copy these two data frames here in a cell, and we need to import something here, that is import. We need to do an import pandas SPD. Then I can just uncomment out these. You can even try maybe to print to see whether you have the data with you. You can have another print here that is copy and try to paste the D2 here and see our output. Let us just give it time to run. Oops, we are getting an error here. Let us see what the error is saying. I think I've left something here. 1, 2, 3, 4. Okay, we can just check. Let us check these. So here you have 4. This is 1, 2, 3, 4. Yeah, I think you can just try to run these. Yeah. So now since now we have two data frames of same size. I think we can now try to merge them and see what will happen after now we have used this pd.merge what dot merge method here, that is d1 and d2, and maybe we can assign this one to a certain variable. We can maybe call it merge data, and even try to print out these. Let's call data here. So you notice that, okay, let me just add a message here. Something like merged data. Let me allow someone here. Okay. Let me just use these. At that point, but at this point. These forward slash and the L, it means just that I'm trying to print whatever it is here on the next line. So you notice that now we have a merged data here. That is the D1 and D2 are now merged, such that we have the num1 and num2 here, and then we have the values. That is the values for B, that is key. Key we have A. That is key we have, is it AB? I don't know why it is not printing all the. It's just printing for the what? All the keys, all the keys that are. You notice that we don't have an A in the second data frame. So it is just printing the. It's just printing for the first one is just printing for the B and C, and you'll notice those are the same values that we have here for this key, that is BC. You notice that to merge this data set is just selecting for all the keys in the first data frame and in the second data frame, that is BC and BC. Then we have the values, that is in B1 in B. Here we have 1, and in the second data frame B is 0. And also we check at C where we have its value is 2, and also we have C at data frame 2, that is D2. We have 1. So to join the to merge, now we are trying to we have just merged uh, the keys, the available keys in both data frames, that is in D1 and in D2. That is what we can join. So that is just one way of joining or merging, because we are told that pandas data automatically based on the key column. You can select the column you want to merge. You will see that in the next merging on multiple columns. But if you just use that is the merge method without even specifying the columns that you want to join, you notice it's just joining the common keys, in our two data frames. I think that is clear. Um, Let us just move on merging multiple columns. And in multiple columns, we are told if the columns names are different, you can specify these columns separately. And I think we will see that soon. I think we can have, let us just have an example here of, again, let us just use key 1 and key 2, that is data frame 3 and data frame 4. Let us just uh, see these in action, whereby we are going to now specify we are going to specify columns. So I think I can just copy these because of time, and let me just copy it here. Where is this? Let me just copy these and we just have a comment here. Where is this? Yeah, I was just trying to replace something here. I think I can just uncomment out these. And then I think you can just let us just try to print out these data and see if we have the data, maybe even the structure of the data. D4. Again, I'm getting something on an error here. All arrays must be of the same length. Let me see this. 1, 2, 3, 4. I think I should reduce this one to 5. Yeah, you notice now I have I have those two. That is the data frame. I think I should rename this so that it can make sense. Data frame underscore 4, underscore 3, and we just have these underscore 4. I think we can also change these. I think now they are making some sense. That is data frame 3 and data frame 4. So now to merge these based on the keys. We are just going to specify the keys that if it is that is maybe key on in the first place you have to specify your data frame's name. I think I should also change this one to data frame 3 and also data frame 4 here. Let me just change that. Then we can now specify the key that is left on. Use the left on and also the right on. So on the left side we should have all the data on the key one, and on the right we should have that data on the key 2. So if I uncomment these and maybe even try to rerun these, you notice that now I'm having in the first place I'm having the data on that is the data on data frame underscore 3 on the left side, and all the data on let's just see this one in a table format. So in the first place I'll have the indexes that is 0 to 2, and then the key and the number value that is 1, 2, and 4, and the other part I have that is on num2. I have that is 0, 1, and 2. You understand that in this data frame of mine here, I'm just using just to get the values. I'm just using they are just numbers in the range of one to five, and the second one I'm using numbers in the range of that is for any number that is within that limit instead of just having to type those numbers. So that is basically what you can that is basically what you can do to merge. That is both data frames, and you can even specify on the what should be on the left key, what should be the left on the left, and maybe what should be on the right. I think someone was asking how to join those data frames yesterday. Was that Peter? I think it was Peter Kanyoi. I think now you have seen how you can do that in case you are asked to do that. Any question regarding this merge before we move on to the other part? Any question? Any question on that? Uh, Brianna, are we good?
Yeah, we're good.
Oh, that's cool. What about Wema? I think that's Eric. Are we together? If you can hear me, Eric. Eric, are you able to hear me?
I'm good.
Okay. So I think we should move forward to the next thing. If we guys you are good with that, and let us just see margin on index. So we are told in some cases the key column to be joined in the data frame can be found on the data frame index. Yeah, and in such cases you need to specify the key the key column to be merged with options of the left index. We we set it to true, and the right index we set it to true also. I think we can see these using these hard coded data sets. Um, yeah, I think we can just check these. Let us just have these again. I want to type these again. Just copy these and comment out everything here. Again, here you are having almost similar data frame, that is letters, and I think we have how many letters here? That is there are about six, and also in the second data frame we have around, that is we have values here, and also we have index. So I think you can just comment out these. In the first place, we said that you must check if you're able to access these data. Let us just try to print out these. E2. I think I should try to comment out these and also import pandas in this cell. What is this? I think we are missing something here. It should be data frame. We have a typo. The solution should be data. Yeah, data frame. That should make now sense. We have letters and we have numbers and we have some values here. So let us just try to combine the data set using the index of the data set on the right. So we can just uncomment these, whereby now we just pass in our data frame 1, data frame 2, and then where do we want to join that? That is on the left letter, and on the right we should have index. We are setting it to true. So if you happen to run these, I think you should be able to see these in the table, whereby we are getting on the left on we have the letters, that is the letters that we had here, that is AA, BB, and C. I don't know why it hasn't displayed C. I think we don't have C in the second data frame. We don't have a C. I think you can change this one to C. So that you can have all the data displayed. Just this again. Yeah, I think even now C is included. Yeah, so when we have letters on the on the on the on the left side, and you notice that on the right now I have the indexes. That is the values at those indexes. You understand that in the values that in what, that is the value I have the values as 3, 5, 7 at indexes A, B, and C. So at instances where I have indexes A, I should have its value as 3, and I think you can just confirm that with what we have here. Like now we are trying to to replace all those values with I mean those letters, those index with their values. Whenever you have maybe an index of that is A, we just replacing it with its value, and that's now we are going to combine the data set using the index of the data set on the right. Just basically like where we have a letter A, we just replace it with its value. Uh, with its value. I think you can see that in what we have here, value and the index. So that is basically that on combining data set using the index on the right, and even you can try maybe using the index on the that is left underscore index, as we have seen here, that we're told to specify the key column to be merged with the options. We have always the left index. You can set it to true, or even the right index. I think we had an example of right index. So I think that is basically that when it comes what to merging. I think even we have another example here. Uh, we have another example here where you have the right, and you also have the data that should appear on the left. I think this one should be quite easy when you're using the join method again. So I think you can just have this. Let us just have this. That is the right and the left. Let us just try to use join method again to let us see the join method in action. Uh, so these are some of the functionalities that you find in these programming languages that maybe you couldn't find. You will have to you'll have to like you'll have like to work you'll have to do a lot of work when it comes to maybe even using these um, when it comes to using the other what the other platforms for analyzing data, like joining the merging data set. Let us just see this last example here. Where is this? You have it here. We have the right and the left. Let us just add something here. You can just say something here. I think you can have these. Even I think you can see these in a table. You notice that on the right we have some columns with that is Tom and team. We have the indexes is A, B, and E, and we have the values is 1, 2, 3, 4, 5, 6. I think that is what we are trying to illustrate here, and that should be on. We are trying to combine. That is the second data frame here that we are calling it left. That is what should appear on the left. That is where we have Sam and Kim on the left, and we have that is left dot join right, and we have the columns of Tom and Tim. The the values is on the right. So it is just quite easy to join these data frames here using the either the merge, or even you can use the join. So it is just that easy to do that. So any question on that? Any question on that? Before we move on to the next thing, I hope I was not fast on that. These are just functions that we are just trying to use to carry out this margin functionality. So any question on that? If no question, I think we can just I think that is all about that was all about joining and merging. And we have something interesting here that you can combine more than two data sets with join method. I think we have seen that. Do we have any question on that before we get into something different? Any question? I think that was all for lecture 10 and 11. So any question on that? Who thinks that we should repeat something? Because I think we are winding up on uh, this Python before we get into maybe something different. Any question regarding that? I got are we good? Okay, I'm waiting for any question. So any question? I want to share something here as I wait for any question. You guys, does it mean you have no question? Okay, if there is no question, I think let me just there is a file that I want to share with you guys. There is a file that I'm checking here just to summarize on Python. So let me just check that file. So any questions as I look for that file? I think losing the file. I should find that file in a few. That is a file on EDA process. maybe I can just take you through. I think I can't locate the file, but you can just check the EDA process. For those of us who are not understanding what is EDA, it's called exploratory data analysis, and I think I'll just take you the process because I can't locate the file. Uh, I don't think I can locate the file at the moment, but you can still do without the file. Uh, so let me just share my screen here. I can't locate that file. I think I can just take you through the whole process. And then yeah, let me just share. So we are talking of an EDA is it's a crucial step in data analysis where you examine and summarize data sets just to understand its main characteristics. Um, so in this case, we are going to use Python throughout the process. And the first step in the EDA, I think we can just have a new file here. Let's just call it EDA. But I look for the file and share with you. I think you will have a better understanding of the EDA process. It's more on what we have been doing, but it's good now to like to have it as a process. So let me just label this file EDA score process. Good. So the first thing that you are going to have here is the first step is always loading the dataset. I think we can just move together. You can also open you can open your tabs. You can have this board. You can have code. I think by now all of us have this dataset. We're going to use the exercise dataset in this case. Um, Let me just try to upload it here. We're going to use this data. Yeah, we're going to use this dataset. So let us just, if you can have it in terms of like steps. Can call this step 1. And, let us just load this dataset. So we are just going to start with imports. That is import pandas pd. So I think by now everybody knows how to read a dataset. And let me just allow someone here to join. Yeah. So we are going to call this df, that is, and we can have pd dot read underscore csv file, and I want to read this file here. You can just copy its path. It is in content, and then we have that. If you can just try to check if you have this data in place. Let's just try to print, and we can just have that is df.head. Yeah, I think we have the data set. Just you can have this one as step one. Loading the data set. After loading the data set, the second step is always to understand your data set. And to understand your data set, maybe you can just try to get the basic to retrieve basic information about your data set. And to do that, maybe data to do with let's say you can even check the nature of your data set, such as the number of maybe columns it has, um, the data types, and also you can have maybe even summary statistics of your data. So by using these head function is one of the functions that will enable you to help you understand about your data. If now we use the head function, you can now get that we have how many columns are these? We have about 5 columns of this data. So the next step is always to understand your data. That is step number 2. And by the way, these are some of the common questions that you get in these interviews. You can be taught uh, to carry out the EDA process on a data set that we might select for you. So the next step is just trying to understand your data set. These you can use something like head function. You can use the info function, that is to get information such as data types of your data set, and even the number of rows your data set has. I think we use that info method uh, sometimes back, but uh, you can have even functions such as describe. I think I didn't touch on this describe function. Just to try to understand the nature of data that you are trying to work with. And I think you can just start with with the head function, whereby we said that with the head function we display the first five, the first five what? It's the first five rows of the data. And I think you have just seen that starting from index 0 to index 4 of the data. I think you can also have these info method, and these will help us to get, just as the word suggests, getting information about uh, getting information about your data set. Oops. Information about your data set. So you can just try and see these. That is df.info. I think I'm getting this error because of indentation. You can just try to run these and see. So you understand. I think I passed all through this information here, but I would it might be repeating it represents. So we are just getting information of uh, the range index. The range index is up to 102. So we have, if the range index is 102, we must be having like around, that is 102, 101, 101 entries or rows of data, simply because we start from index 0. I think even um, we are told here that we have entries from 0 to 101. We are told that we have the data columns, so we have total number of columns uh, is 5. We even go further to even get the data types of those columns, such as we have column 0 to 4, whereby we are getting the data types. We have float, we have float, we have float, we have object. Um, so we are told also we have three types of data types. That is the float. I mean we just have two types of data types here. That is the float, and we have the object. And also even we get the information about um, the what the storage that this data has taken from our available memory. So that is 4.1 kilobytes. I think we can also check the describe um, the describe the describe function. This one will basically give us it's called the summary statistics. Summary statistics. Statistics. That is the right spelling. That is the summary statistics of the data set. Uh, so again, this one is even quite easy again to implement, because again we're just going to invoke our data frame, that is df dot describe. You can have the describe there. That is the right. I'm hoping that that is the right syntax. You can just try and run this and see what you're going to get here. Yeah, this is basically the summary statistics of Let me just try to print something here. Summary statistics. Summary statistic of our data set. If I try to run it again, I think, yeah, we have the summary statistics of the data set. We have that is the on column duration, the calories burned, and heart rate. You can also see this one as a form of a table. And some of the information that you're going to get using this described method here, we are going to get the count. We are going to get something like mean, standard deviation. We have the minimum value in in a certain column. You're going to have the quartile. We have the interquartile, and we have the 75. How do we call it? We have the quartile. We have the inter. What is the name of this one? The 75%. I think it has a name.
Third quartile.
Yeah. It's that quartile. I think it's the third quartile of the third quartile, and also you're going to have the maximum again value. We have the maximum value here. So you understand that we had how many columns? We had the duration column, we have the calories burned, we have the heart rate. So I think this is just quite like it's quite self-explanatory. It's just simple to understand because I think it's just by itself you can it's easy to understand. It's just easy to understand because you
A
have
quick one.
yes.
How are you expanding that? Because initially, when the system rolls out the information, it's rolling it out in a smaller, but you are expanding those columns.
Yeah, okay.
How are you expanding that?
I think I can just repeat that. You can just run this, and you can just use you can just on your right you have something like a table here that is telling you to convert this data frame into an interactive table. I think when you press that, you can get this, and even it can suggest for you the charts that you can create with such kind of data. But to make it a table, you just have to press this. Let me just try to run this. And you're just going to press this table structure over here. When you put your cursor on it, it will you'll have a message of converting this data frame into interactive table. So again, that is basically that. I think you know what is mean. You know the count we have like about um, we have like about is it 97. That is null values include exclusive. We don't include the null values here in this case. But you know the mean. I think we saw how to check the mean. We even have functions for checking the standard deviation. It's only that we don't have time. We could maybe verify this data, but this is the right data. That's the mean. We have the minimum value as 2 in duration. We have the first quarter is 38%. You notice that with this table, we have a lot of information already about this kind of a data set, and this will happen for even data set with over 100,000 rows of data. So you can see how that function is simplifying the work. So that was about getting information about your data set. And now after understanding what kind of data you are dealing with, we can go to the third step, whereby now you start. I think how I could approach this, maybe let me see this. I think I can have, let me just cut this. Let me just add another for step 2 here. I think you can separate these in terms of steps, so that we can have step 1 in its own cell, we have step 2 in its own cell. That one will be better. So let us just come to step 3. So in step 3, what we do in the step 3 of the EDA process is now handling the missing value in the dataset. And remember, in here we used methods such as, can you guys remember? Just I think we can have 3 methods here, and you guys, you are the one to tell me the methods here that we used. The first method was can you guys name these very fast, because you already have them. So the first one was very fast. Peter, can you I think you can give us one. We have Alvin and Winnie Abogo to give. Yeah, you guys, you can give us those methods. Starting with Peter. Peter, what was the first method? Peter?
Okay, null values, removing null values.
Okay, how do we do that? The functions that we use.
The drop and A.
Oh, the drop and A. Alvin?
You can use the forward fill method.
The forward fill method, which is the method?
You write fill and A.
Fill and A method, right?
Then open brackets, then you can write f fill method is equals to f fill, sorry, in quotation marks.
The method is equals to f?
Method is equals to, in quotation marks, double F-I-L, double L.
Just a minute. So you are saying method
is equals to you in quotation marks F double F I double L.
I double L, like that. F.
Yes.
That is the F. Yeah. Okay, Winnie Abogo, the last one. Winnie Abogo, you don't want to give us at least one method. You can even maybe check if it's null. I think that method also is part of hard missing values. So the first thing I think that is this is quite easy with these kind of methods. I think we can start with the first method to we can even check, we can even maybe print maybe the number of null values so that we can get these. So we can have the f, our df dot is null. I just want us to check the number of null values that we have in this data set of ours. So with just this line of code, we are going to get the df, and we are checking its null value, and we just want to take the sum of all null values. So if I try to print out these, you notice that I'm going to get another. I'm going to get the sum the sum of null values in each column. So in the exercise type, we have null duration, we have like 5, and in calories burned, we have like 7. Heat rate, we have 5, and in dates, we have 10. So again, it's up now to you you can decide to drop, or you can decide to fill. But because of time, what I'm just going to do is just I'm going just to use a simple method here to drop all the rows with let me just try to drop all the rows with missing values and how I do that, I just use the df dot which method do I use here? Is it the drop now method? I think that should drop all the and we were passing something here that is in place. We can say that row true. Yeah, I think that should, and even we can just run this again after dropping, just to check if we have a different output. Yes. I think in the first place we had these all columns with some missing values, but after now dropping all the rows with missing values, you notice that now I have when I try to check the print sum for null values, I'm getting all of them as 0 because we have successfully dropped uh, those values. So I can just delete this. So in here you can use the fill now method. There are so many methods that you can use to even fill the missing values instead of dropping dropping the rows with missing values. You can replace them. Those are the kind of uh, Those are the kind of operations that you can do here, trying to handle the missing values. And I think we checked a couple of methods here. So after I've shared this document, you will try to add some other values, other functionalities on your own. Um, so far, are we good up to that point? Thumbs up if you are good up to that point. Uh, Thumbs up for those who are following so far. We have Kinawini, we have Brianna. I think most of us are following and good. What about Nyamoya? Nyamoya, are we good up to that point? We have Winnie, we have so someone was telling me it's also called the upper quarter, not sure. So I think we can just move to the next step. So just make use of the other methods here. So let us just move to the fourth. Is it the fourth? Yeah, the fourth step in the process. And in here, you're going to do data visualization. This is where you're going to do the data visualization. I think that is was our second last part of someone want to join. Let me see this. Where are we? Oh, yeah, you are here. Yeah, that was the second last part of our discussion. That is data visualization. And in data visualization, we used methods such as in here we use charts. I think we used histogram. We have pie charts. We have scatter plots. So visualize the data using plots to gain insight. These are just for this one will help us just to gain insight in the relationship between the variables. And I think we used matplotlib here just to try to visualize data. I think you can have I think you can just have a histogram. I think you can just draw a histogram. You can just draw a histogram, and in here I'll just import. I'll have to import. We'll have to import matplotlib, SPLT Just to make it easy, I'll also import another library that is called Seedborn. This is also another library that you guys should check on. It's called Seedborn. We used to usually import in Seedborn, not Seedborn. It's called Seedborn. Yeah, Seedborn is an S. Yeah, use Seedborn as an S. Again, it's used for it will help us to do some plots easily. So let us just have histogram of numerical values in our data frame. Let me just indicate that. That is histogram of is it numerical values? The numerical values in the data set. So in here you can just call the CNS dot hist plot, and then here you're just going to pass our df, which has some columns here such as we have exercise type. Is exercise type of let us just have I think you can have duration. You can have duration, we can have heart underscore rate, we can have what else should we check? Heart rate, duration, then calories burned. Calories underscore burned. This one should be instead quotes. So after that, you can just plt show plt dot show these and see what kind of oops, we are getting an error here. What is it saying? We have a list like just try to cut these and see. Yeah, this is a histoplot for duration. We can have even a histoplot for something like let me just choose one. Let me have heart rate. I can just type heart underscore rate and see that. This is so bad. I don't want that. Let me just comment out this. yeah, you notice that now I have a histogram plot for the heart rate. You can even have a scatter plot. Let me just have another scatter plot here very fast. Scatter plot. In this case, let me have a scatter plot of two numerical values, not variables. You can just call them variables. I think that will make more sense. So again, I can just use a SNS dot. We have scatter plot. That is the scatter plot. And then in here, you're just going to pass the x. You can have the x-axis. I think you can just have on x-axis. I think we can have something like duration. That is duration. And on the y-axis, we can have something like the calories burned. That will make sense. The calories underscore burned. I'm hoping that is the right spell. I think I used U instead of A. So I can use the PLT dot show method again to show the scatters. And let me just try to run these out. I'm getting simply because I have not passed the data is equals to our df. That is what I'm missing. Yeah, and you notice now that I have I interchanged these. This is what it should be in the y-axis. Let me just cut these in. You can have this one is our y-axis and this one has our x-axis. Yeah, I think that's okay. So let me just try to run these and see. What am I missing? Is it a comma? Yes, I was missing a comma there. Yeah, I think that's okay. It is. Now I have a duration on the y-axis and the calories burned on the x-axis. So after data visualization, we can have other steps such as feature engineering. You know, so this one was step. Let me just include this. This is usually the step number 4. We can have another step over here. Let me just have this step here. That is step number 5. And this one is on feature engineering. Feature engineering. Yeah, feature engineering. Being our step number 5. So with feature engineering, you can create new features or modify existing features just to improve the model performance. Um, so feature engineering, you can decide to create a new feature, and how we do that is just quite it's quite simple. Because I think this is something we have. I don't think we have done this. Uh, but you can just decide to what should you add. Should you add in this or data frame? You can maybe have a feature like what? Let me just see. You have the calories bar. I can just decide maybe to have the name of the person who is taking this exercise. So you can maybe let me just let us just have the first name for maybe for the person who is taking the exercise. Then you're just going to equate that one to df. In here you can just try to add some features, something like maybe let's have feature one, because in this case I understand I have a lot of I have 101, is it 101 101 101 errors of data. So I won't keep like typing all those data, but this is something that you can try. So you just equate your df, whatever row you want to add, that is the row for the column for the first name. Then you can indicate maybe the values for that. I think with these, let me just indicate here. We are trying just to create a new feature. New feature. So in this case, you were trying to add a name. Exercise. The person who is taking the exercise stuff. Exercise. I think you'll have to try these. You'll have to try these out so that I can at least pass through the next two steps. So the sixth step here, and these are things that you should know offhand in case you are asked. You can carry out it's called the correlation. That is the correlation analysis. So in the correlation analysis, you just check the correlation between variables to understand the relationship. And in most cases, to check the correlation, we can let us just even maybe try to calculate the correlation here. You can just form a correlation matrix. Let us just have that correlation underscore matrix here, which is equals to df, use the call method here, and with this we can create the correlation, but we can see the correlation. We can calculate the correlation. Let me just add that. This is calculating the correlation matrix. Oh shit, I think I have a typo here. It should be correlation matrix. Yeah. I think you can even type this and see. But you notice here we are getting a feature one in the default value for numeric, value for numeric on in the data frame call is duplicated. Feature version it will be default for select only valid columns. For this, I think you're getting this because we have uh, we have um, we have columns that that do not have that do not have do not have what do not have numeric values. But just to visualize that, let us just try to visualize this using something that is called just visualize this using heat map. Call it heat map. Let us just see this heat map. Then we just try to pass this here. And we have another attribute that is called anode. You can pass this one to true. And let us just have a PLT dot show. I'm hoping it will just try to give us the values for only the what only the numeric values. So this is just the correlation the correlation between these variables, that is the duration, the correlation between that is the duration and the rest of the columns. That is why we have the duration. We have some values here just to indicate the correlation, because you understand that we have just generated a matrix of 3 by 3 matrix just to show the correlation between these values. I think you can just reach out because of time. I'll show you how to maybe to even explain these values here. But this is basically the heat map. We call it the heat map. It's used to show the correlation between columns. The last step that you can have in the EDA is something that we call that is step number 7. We have something that we call outlier detection. For the outlier detection. So with the outlier detection here, you just like trying to identify those the outliers. You identify and handle the outliers in your data set. Um, so how we do that, you can use a box plot to visualize the outliers. Box plot is another plot that is used to called the box plot. This is a plot that is used to visualize the outliers, visualize the the out the outliers. Um, and it's just quite simple to implement this because by just 2 lines of code you can easily tell uh, and some of the outliers just to mention is, let's say you have I think this is something that I had said. Let's say you are checking the height of dogs and then you realize that in the height of dogs the height of dogs should be between maybe 0.5 to maybe even to 5, or not really 5 but around 4 feet. But if you get a dog that maybe you get a value there that is maybe 20 feet, you begin to wonder. You automatically know that that one is an outlier in your in your what in your data So let me just show you how to visualize that using the box plot. The box plot. Uh, these are some of the plots that will help you to know the kind of data that you are dealing with, and again, even since some values that are not, let me use the word, the values that are not logical, maybe in whatever case, um, what maybe in various columns of your dataset. So you usually just pass the the x, just the x column. You can even pass maybe duration. You have duration, and you just pass the your data, which is equals to df. And you can just try to maybe blt show this to show. Let us just try to show this. And I'm hoping we should get a box plot here. But you notice in this box plot, um, with this box plot, I think we don't have outliers in this duration in this duration in this duration column. Maybe let me just use a different column here. See how it will behave. Maybe should I use the hard column? Um, hmm. Yeah, let me just use the hard range and see what will be the output here. To the score. Again, here we think our box plot here is just normal, because you realize that you have this line. It's almost at the center here. So maybe later on I'll give a data set with some outliers, and you will notice that. I think that there are ways to remove the outliers. Let me just show you how to remove the outliers, just to finish on this process. The outliers. We have several methods, but I'll just show you one that is called it's called the Z-scope. It's quite common with removing of outliers. So we just have from CSPy. Let's start again. You realize that these are other libraries for Python. I think we didn't have enough time to check through these, but you can check you can check them on your own. They are quite similar to what you were just doing. So let me just have the DF here. In this DF of mine, I just want to use the np.abs method, and I'll just pass in the Z-scope. I'm hoping this is the right what? The right. I'm hoping this is the right syntax for this. I just want all the values that are greater than so you're using the heart rate. All the values that are greater than 200 will be treated as outliers. So I'll just have that, and there's something that I'm missing here, that is df np.abs. That is called this. Yeah, this one should be closed. Dot all.
That's a less than sign.
I used a less than yes, so that now it can treat all the values that are greater.
That's a less than 200 sign.
Yes, I'm saying. Yeah, should be greater than, not less than sign. Greater than that, all. Then they just have to pass axis is equals to 1. Then it should be. This is where I pressed. It is usually yeah, I'm missing something here. We should have parentheses there, an opening parenthesis, and then np.abs, then z-score, then we pass in the df values greater than 200, then dot all. So yeah, so that now I can close. Yeah, it should not be here, but I should close it. That. Am I missing something here? We are talking of np not defined, so it is import that is numpy is np. Hoping now we don't have a problem. then I can just try to run through this, but again I'm getting an issue here. I was talking of casting. Let me try to use something like duration. Should I use something like duration here? Oh, yeah, I'm simply getting this because of what? Because I have in my data, I have something. I have a row. Let me just check the kind of data I have here. I can have df.head. I think I have a column that doesn't contain numeric values. Yeah. I don't know it is taking time. I have these exercise type. I have this exercise type as headers or dates. So in this case, I should use only three columns. That is the duration, the calories burned, and the heart rate. So to remove the outliers, I think what you are going to do here. Let me just specify the steps that you're going to take here. You're just going to drop, because of time, I'm going to drop, that is the exercise type and dates column. And then after that, you can just try to run through now these. You should be able to achieve removing outlier functionality. So that is the 7 steps that you should follow to achieve the EDA process. Or the EDA process consists of these steps. And anytime that you are given data for analysis, this is what you should. This is what that should guide you. I think we have I've taken more than is it more than 30 minutes? But it's okay. I'm thinking that Peter, can you know you are you have got an understanding of what an EDA process consists of, right? Do you have any question? Yeah, that is the whole process of the EDA. It could just consist of those steps. So I don't know if there is any other question regarding the EDA process. But in here, because I hear this file, using the drop method, just try to drop these columns. That is the exercise type and the dates column. I think there is a question. Who is having a question? Yes, there is Peter. Peter, what is your question?
Yeah, okay. So in statistics, are we supposed to, how do we deal with outliers? Because do we remove them completely from the data? We do analysis with with outliers?
No,
Then
no.
if
Yes.
so, how do you handle them?
Yes.
If there is no any errors in data entry or nini, kila kitu iko sawa, but the presence of outliers in the data.
Oh, so what should happen? Because now you are doing an analysis, and you know that outliers. These are data points that should not actually exist in your data set. So you using them, using a data set without trials, you are definitely going to get wrong results, right? So you should remove the outliers from your data set, and then save the data that doesn't have the outliers for you know to yes.
Okay, I'm basing it from because I've heard of a nini during our lectures. They say we use Kickstarter in classroom.
Mhm.
So the reasoning is you're supposed to do analysis with presence of outliers.
Mhm.
Then you do another analysis separate with no outliers.
Mhm.
If there is no any big difference between the two, if there is no big difference, then you proceed like that. But if there they are affecting the outliers, when you do analysis of the outliers and with no outliers, if there is a big difference,
Mhm.
then use other methods that are more advanced. So I was wondering whether for Python you must remove them completely.
Yes, you have to, because the main aim here of the analysis is to get the right result, right? And
Yeah.
you might not even have that time, maybe even to do multiple analysis or two analysis, and then comparing the two analysis, knowing very well that outlier. Let me just give you an example of where you have maybe a data set that is maybe containing what maybe population, is it? That is not the best. Let me just stick to the example that I was just giving. You are doing analysis on maybe heights of different dogs, and then you realize that it happens that in your dataset you have heights that are even uh, heights heights values that are even more than 20 feet, and it happened that maybe there are several. So in your analysis, you are definitely going to get maybe you might get the wrong. You will definitely have maybe have a wrong maybe analysis, simply because those outliers will affect will affect your results, and that is why we are trying to check if we have outliers in your data set, and then from that point you can now remove them, and then carry out analysis uh, with no now outliers. With these programming languages, I think the best way to deal with these outliers is to remove them. To remove them. Are we together up to that point?
Yes.
Yes, someone is aware. Peter Kanyo is asking I share the file. Yes, I'll share this file with you, so that even you can carry out some other methods in these steps on your on your on your own. Uh, I think we can finish at that point. You can just call it. You can just call it. It was just the final what? The final parts of our discussion about um, Python for data analysis. So what you guys should be expecting tomorrow now is getting into something something a bit different, that is introduction to machine learning, and see now how we can now use machine learning to even have better uh, uh, to even have better better methods of dealing with these data, or even see like create models that can learn from data, and maybe try to it always depends on what you want to do with ML machine learning. So we can have even models that can maybe help you to predict to predict something. We call it forecasting. Um, so having said that, I think we can just drop. Of course, like I see we are past our usual time with around 39 minutes. So if we guys we don't have another question, I think we can we'll have to drop off. Or do we have another question regarding uh, uh, this Python part? I don't think so. We guys, I think we can call it a day, and wishing you is it a good night? Yes, let me just wish you a good night. We see each other tomorrow. So bye.